I'm coming from Moldova. Moldova is a little country between Ukraine and Romania. So we are very close, 200 kilometers from the front line between Russia and Ukraine. I teach at Pedagogical State University in Chisinau. I teach theoretical physics, and at the same time, I'm a PhD advisor in educational sciences. So today I will present the issue how to reach constructivism in school physics lab. So how to pass from traditional labs to a constructivist one. As you can see here, it should be based, this transition, on collaborative inquiry, open-ended investigation, and knowledge construction through peer interaction. So, in the first section of my presentation, we will discuss about limitations of traditional labs and analyze three dimension and three educational values which form the foundation of our model, constructivist model. In the second part, we'll connect these three dimensions and three values with well-known 5E model. And finally, I will present the results of implementing during one academic year this model in 8th grade class. 8th grade means in our country 14, 15 years old. And finally, we will summarize the main conclusions. The next slide, it's about deficiencies of traditional labs. So there are many deficiencies, but we will underline shortly four shortcomings. First of all, lack of student autonomy and engagement. It means experiments in traditional school labs follow pre-established recipes, like a cooking book. And this prevents students from formulating questions or making decisions about their activity in school laboratory. Finally, it contradicts with the principle of student-centered learning, and it critically reduces students' involvement, and finally, a sense of student agency in the learning process. The second is also emphasis on procedural correctness, and the lack, as a result, the lack of conceptual understanding. So, because students are encouraged to follow fixed steps and obtain expected result, and so in such a way, this process doesn't foster a deep understanding of studied phenomena. As a result, students perceive knowledge as rigid, coming from an external authority, in this case, the teacher. So rather than knowledge is a product of their cognitive effort. And the third point, lack of development of research and experimentation skills, because students are focused on confirming already known laws rather than investigating open-ended questions. In such a way, students do not develop essential scientific thinking skills, such as formulating hypotheses, analyzing variables, or interpreting their results. And the fourth shortcoming is reduced collaboration and social interaction. We should underline that learning nowadays in modern times isn't transmitted, knowledge isn't transmitted, knowledge should be negotiated within permanent collaboration and interaction between students and teacher. So communication and teamwork is essential in science. And these aspects are neglected in traditional experiment structure. So the main problem is to bring the nature of science in classroom. Next slide is about the three dimensions of our model. First of all, I would like to say that according to the data provided by the Center for Educational Evaluation and Analysis in Romania, which conducted a nationwide program implementing physics learning through inquiry-based science education, IBSE, it was found that specific competence in physics reached an average of 3.69 in experimental groups and only 3.0 in control groups. In the system of 5-point scale. In order to achieve these results, a constructivist laboratory was developed, relying on three essential dimensions. First of all, collaborative inquiry and problem framing, which provides students to the opportunity to learn physics by practicing physics. Research shows that involving students in formulating questions and structuring their own investigation improves conceptual understanding and develops scientific reasoning skills. In this sense, Dashel and Baby in 2014 recommend 5D model, which means these students are the ones who decide what and how to measure, develop, and choose measurement and data collection procedures, document and record measurement and observation results, devise representation for structuring data, and determine if the obtained data is good and reliable. Second, experimental design through open-ended investigation represents an approach where students formulate questions, choose experimental methods, collect and analyze data without having predetermined outcomes. This process reflects the real way in which scientific researchers discover and validate knowledge. So it reflects the nature of science. Hanson and led in 2016. And the third dimension, knowledge construction through peer interaction, emphasizes the essential role of collaboration between students in the learning process. So, as we know, the number of interactions determine the success of didactical process. Because often group results exceeds the individual results, the results of its best members. See Smith, 2009. Next slide is about three educational values of our model. The first value is epistemic agency, which refers to the student's ability to make an active role in the scientific inquiry process. So in such a way, laboratory becomes an environment where students learn how to think from a scientific perspective and develop intellectual autonomy. So finally, it forms strong intrinsic motivation and greater commitment for learning activity. See Desi and Ryan in 2000. The second value is structured openness. It represents the balance between structure and freedom, offering students the opportunity to explore ideas and phenomena independently, but being guided by a well-defined methodological framework by teacher. And third, distributed cognition. It means interaction of students among them, students and teachers, students and resources, and students and tool. See Chakmakchi et al. In 2020. So finally, this model, it's about how to reach cognitive engagement and in the same time autonomy. Cognitive engagement finally will lead us to the ownership of cognitive goals. So in such a way, we will transform the didactical goals of the teacher into learning goals of students. And here is described the constructivist model of school physics lab. It is based on well-known 5E model: engage, explore, explain, elaborate, and evaluate, which was proposed by Baby in 2006. It is grounded also on the concept of inquiry-based science education. It implies mandatory group work or collaborative learning and self-directed experimental inquiry, SDI, in order to underline student autonomy. Now, it is the framework for the Constructivist Physics Lab. This table describes the correlation between 5E phases and free dimension and free educational values. Three dimensions: collaborative inquiry, experimental design, knowledge construction through interaction, and three values: epistemic agency, structured openness, and distributed cognition. As you can see here, in the first phase, engage, the students are the ones who formulates the question and frame the problem. And at the same time, the teacher's role is to guide their discussion. In the explore phase, students investigate the phenomenon within group work and decide how to collect data. And the teacher role is to provide guidance without imposing rigid methods. So maintaining in such a way structured openness and distribution cognition also is manifested through the use of diverse resources and active collaboration between students. The next three phases of 5E model and their correlation with three dimensions and three educational values here. In the explain phase, students analyze experimental data and construct explanation through collaboration. So it is about collaborative inquiry and problem framing. And teacher provides a conceptual framework which facilitates understanding without, at this phase, imposing a single interpretation. In the elaborate phase, students extend their knowledge by formulating new questions and designing additional investigation. Teacher here helps students to integrate their different views into common, correct structure. And finally, in evaluate phase, students self-assess their progress, their process, adjust their conception through discussion with peers, and teacher supports this reflection by providing clear evaluation criteria. And here on this slide, we have the results of our pilot project, which lasted one academic year, 2023-24, in 8th grade, 2 classes. And the total number of students, 72 students. Let's analyze this data. As you can see here, in pre-test, the marks were already high in the system of 10 scale system, yes. The median, so the mark of the student which is in the middle of the list was 8 in pre-test and 850 in post-test increased. Also, the most frequent mark in pre-test was 8, and the most frequent mark in post-test was even 10. The mean also increased from 775 to 8375. If we will analyze skewness, yes, we will understand that in pre-test, the majority of marks are concentrated in the area of higher marks, and this fact increased in post-test. So the majority of marks are concentrated in the area of high marks. Shapiro-Wilk test also confirms its p-value. Shapiro-Wilk test confirms that this data have statistical meaning. Also, our results that learning gain was 0.38. It is not so high because of already high pre-test marks. Effect size was 0.63. It means that it is close to cooperative learning, close to problem solving, 0.61, and close to metacognition based strategies, 0.68. Here we have to mention that traditional teaching has an effect of effect size 0.40. So our results is an effect size of moderate to strong impact factor. So it is more than 50% higher than traditional teaching. Traditional teaching, it means a good teacher teach during 2 years in the same class, and results will be 0.40. And our results is 0.63. In conclusion, a constructivist framework could be built based on a 5E model, based on IBSC group work and SDI concepts, and constructivist, let's say, mandatory dimensions: collaborative inquiry, open-ended investigation, and knowledge construction. Educational values: epistemic agency, structured openness, and distributed cognition. And if you will apply this 4 points, you could achieve an effect size of 0.63. So thank you for your attention.